We good? Hello? Hello, everyone. My name is Neil Sinclair. I'm just going to give a small presentation on some congestion testing that we do at the application level. So you're probably all aware of the modem level testing that we do on the bench with the UXM using the CR limit tests. These fill the RF spectrum with PC5 data, which the modems have to measure and then try to work out where there are holes in the spectrum that the modem can actually transmit, and if there's any throttling that needs to be done or any data priority calls that need to be made. However, when you get to the application level, things are conceptually simpler, but the amount of processing the devices need to do becomes enormous. So every incoming message needs to have its security verified, as we all know. Then the misbehavior detection algorithms need to kick in. They're going to have to track every single station and every message from that station, and then correlate adjacent messages, make sure that, for example, the position between one and the other matches the speed and matches the heading, and do all the values that are being reported here, are they realistic compared to everybody else as well. Then on the heads-up display, every single station that's been received will probably need to be displayed on a map. On top of that, you've then got to filter out stations that you don't care about. So you've got, are the stations in front of you, behind you, left, right, traveling the opposite direction, and then just filter that down to the individual stations that you really need to care about. And for the US region, that can involve 500 stations at 10 hertz, and that will fill the entire 20 megahertz bandwidth. So if you do all the mathematics, you're then up at 5,000 application level messages per second that your application needs to handle. Now that's an awful lot of OBUs that you would need to simulate that in a real environment. So what we have here is something from Qualcomm's congestion control scenario study. That had 50 congestion stations, all of which were stationary, and that's what you're seeing here. And so that gives you some idea of the amount of hardware that you would need to be able to test this out in the field. So what I'm going to introduce is a few tools that Keysight make, which allow you to do similar testing or heavier testing on the bench. They offer you great flexibility and can produce extremely heavy congestion scenarios with relative ease. So first we have this one here. This is the Keysight Director software. And what it does is it coordinates our ITS stack and the UXM modem, which you've probably seen already. It can generate realistic congestion data at the application level using that same UXM. So Director normally controls the GNSS scenario that you get given to your device. And it can use that same information to generate the congestion stations along the same path, so they've got them following in ahead, and you can have flexible lane positionings and speeds. So what we have here is very simple, 4 lanes, 2 going forward, 2 in reverse, and different speeds. So Director can generate the full theoretical 500 congestion stations if we're going to stick to 10 hertz. And that should saturate the entire 20 meg bandwidth. If we disable HARC, which is abnormal from a modem perspective, but probably okay for the application level saturation, then we can get up to 1,000 different stations which can be received by your application. It can also vary the RF power level for each station. So the stations on the outside will be received by the device at a lower power level than those right next to it, which will be much higher. So a much more realistic RF environment for the device. And finally, we have a monitoring tool, which gives you an independent view of what's happening. So some of you may already be aware of the WaveB Touch tablet, because I know Randy likes to bring one along with him. In its tablet form, the WaveB is a CV2X sniffer with an independent modem, which can decode and display all the messages it receives. There's also this one here, which is a Windows variant of it, which can connect to various modems, including the UXM, which the Director software controls. So earlier on, I created a scenario that Director can replay. So as you can see here, it's a simple path that goes along the I-4, which is just up the road somewhere. And Director would normally convert that into a GNSS scenario, which we'd replay out and into your device, so the device would believe it's physically moving along that particular road. So we're going to try and put all of that together, and this will take a little while. Duplicate. If the thing behaves itself. Come on. Right, so we have on the left here, we have director, and on the right, we have the touch as we described earlier on. So I'm going to start up the scenario, and what this is now doing is it's going to generate that scenario, extract the GNSS data, and then try to program an MXG. We're offline, so it's not going to do that point. And what we should see shortly is a device appearing on WP Touch, and it's traveling down the road as we programmed. So if we now start up the congestion, we should see something going on. So you can see here we've got 4 lanes, that's 2 in the forward, 2 in the back, and okay. Oh, okay. Try again. Okay. All right, restart. Okay, so take 2. You can now see this would be your device under test, and it is traveling down the I-4 as we expected. If we kick off the congestion, you've now got your congestion station going. And you can see we've got 4 lanes going on here and in both directions, with a lot of them overtaking the host station. We zoom out, we can see the number of stations you're going to have to process. Half of these you don't care about because they're going in the opposite direction, other half you do. So if we think about what's going to happen at the application level itself, every one of these stations passing you is probably going to generate a blind spot warning detection. Maybe if you think about the opposite direction, what if there's a hard braking event? You don't care about it, it's going in the opposite direction, that needs to be filtered out. Any station in front of you, if you have a hard braking event, that needs to be displayed and displayed importantly. Is that more or less important than these blind spot warnings if you wanted to move out? So there's a lot of information you've got to process and a lot of priority calls your application has to make and make sure just the important stuff gets to the user. So that's basically all I wanted to show you about our congestion at the application level. As I noted earlier on, the same UXM modem can do modem level testing with saturating lots of PC5. You've got MCSRB measurements, spectrum analyzers, the whole shoot and match. Anyone, any questions, comments? Oh, okay, thank you for your time. And I'll pass over to Wheaties. Yeah. Ooh.
You don't have audio on your presentation, right? No, you can just turn it over. I think we saw a glimpse coming up. Oh, you saw it? Try it again. Go ahead and connect again. I think we may have to reboot the laptop, but let's try this. Before you do it, let's try this on our escape bar. Come over. Alright, let's try this, and what I'll do is I'll give you a clicker. You have your presentation up?
Yeah. Yes. I've never used this.
Oh, so forward, back, and then you have a green laser.
Okay.
Good afternoon, everyone. My name is Dave Sir from Wales. I'm glad to be standing here for this presentation. Thank you for this opportunity. Thank you very much. So this is about a congestion traffic generator, our product, aka CGTS. So first of all, let me introduce our company. There is a, yeah, our sibling companies are Cuba America and the MSL. Cuba America plays a role of global sales and marketing, and the way it is it's about B2X test solutions. And MSL is semiconductor distribution. We all under wireless Korean-based company, and it's under LIG. LIG is one of the largest companies in Korea, just like Samsung or LG. much better. Thank you. So congestion environment test system, aka CGTS. As you see, this is our product. Yeah, let me skip this slide. So basically, it is showing us what CGTS is. So CGTS has 5 V2X modems, and each modem can generate 40 BSM messages per second, which is for vehicles, for OBUs. So one unit of a CGTS can simulate 20 OBUs. Yeah, CGTS system overview. A physical component. It consists of VTX radio unit and message generator and control center. But we can put more the radio unit as many as we want, so the scalability is unlimited technically. Again, one unit can simulate 20 OBUs or 20 vehicles. So this is pretty much a technical stuff, and I believe that everyone here knows very well about this. Yep, from here. So actually last year there was a big project led by Korea Expressway Corporation, which is under Korea Ministry of Land, Infrastructure and Transport. So that project was about the congestion control situation. So Waze provided the CGTS 16 units to simulate 160 OBUs. Like this, we put 16 vehicles over there like that, and each vehicle there has one CGTS unit. So 16 vehicles with the 16 CGTS units. So 160 virtual OBUs were making a congestion situation. So one DUT, so there was the testing car with one DUT. Yeah, it was driving around the real cars, and there's a sniffer collecting BSM messages from this DUT to see how it reacts to congestion control the situation. And it was done very well. So this year, another project is planning actually. So we expect better, more complicated situation, the simulated the project late this year. This is another project. We provided 8 units of CGTS generating 800 BSM messages per second. It's a lab testing environment, so we put 8 units of CGTS here, and with the sniffer, yeah, and we are collecting the BSM from DUT to see how it reacts again to the 800 other BSM messages. Yeah, it was done last year as well. Very much well, yeah. Yeah. so far it was about CGTS. And if there's a time, let me introduce our product. Is it okay? Yeah, thank you. So it's RPTS, it evaluates RSU performance. So it collects messages from RSU alongside the road. And yeah, it see if there's the packet loss, like a PER. So we drive a car with this product, the car, and then collect messages from RSU, and then analyze about the PDR. Yeah, this is how it looks. And this is a real output example. So when we done that project, so configuration settings, and that was the output. And one region shows RSU PR status. That is alongside of the highway. And this is a very interesting part. So actually, there is an ongoing project in Korea. It's a very important pilot project to see if VTX service is ready in Korea. So I left in the middle of project actually. So it was ongoing about highway VTX service readiness. And then now it is ongoing with urban area VTX service readiness. So we made a V2X service analyzer, aka VSA. It is being used for this project led by Korea Expressway Corporation, which is under Korea Ministry of Land Infrastructure and Transport, as I said. And this project is covering 40 RSUs alongside the highway as well as urban road or urban environment, and all the V2X services in Korea. So this project is very important because if this project is not going well, probably the V2X future in Korea could be doomed. Yeah, this tool, VSA analyzes PK file collected by a V2X sniffer, and it contains the PK file contains a VSA message from testing overviews and team, RSA, SPED, and map data messages from RSU. So it shows all the route along the way, and then it check the service is triggered very well upon the RSU services. Yeah, this is an ongoing project in Korea now. And it shows the route tracking. Where left hand side is urban area analysis, and the right hand side is highway result. These labels are like triggered by OBU upon the RSA services or VTEX services. Thank you. Thank you. Yeah. It's a very difficult question. Yeah, I hope I can answer it, but I don't know yet.
Very good. What are you seeing in the testing that we're using at this Plugfest?
I'm sorry?
What are some observations that you have from you're seeing at this Plugfest
Yeah.
with the way you conduct?
Sorry, actually, for me, this is the first time to join this the Plugfest, and yeah, frankly, it's been only 2 months since I joined the wages, so everything is very new and challenging. But for me, it's very interesting the stuff, yeah, and it looks like full of passionate and technology stuff. Yeah, thank you very much.
Hello, this is Randy. We're going to enter our last testing session here in the SCMS. Folks are going to have a working group session, which I believe Aaron is leading, so he should be coming over here soon. As far as congestion control from the waves, it does take power, and it is over the air for their test system. They don't have it wired here like at 8 o'clock tomorrow morning, and we will try to run the weightage test as an open air in the facility, starting like at 8:15. They say it should take less than 30 minutes to do that. More of the OUs will be the better. And the question from the Keysight system, yours is all simulated and in a wired scenario for your setting. Do you have it where you can actually broadcast it wirelessly over those vehicles? So is that something that you want to try? And really, because the issue with the weightage tool is you have it in modules, but they only brought one module order to demonstrate it, and it simulates 20 vehicles. In order to get things to change, you need to be at least 25, preferably more like 50. Okay, so is it a special antenna or is it any over-the-air antenna? We could try it in. I have antennas and that type of stuff. So we'll try to do